Hello, AP Chem students, and welcome to topic 7.2, direction of reversible reactions. The learning objective for today is 7.2.a, explain the relationship between the direction in which a reversible reaction proceeds and the relative rates of the forward and reverse reactions. So let's look at it. There are essentially three statuses for reversible reactions, and we're going to look at each one of those. So we're going to start with the situation in which the rate of the forward reaction is greater than the rate of the reverse reaction. What this means is we say that this reaction lies to the right or towards the products. In this case, the reaction favors the products for the forward reaction, meaning that products are being formed faster than reactants. And we see this pretty often. So if you introduce just the reactants into a flask and there's nothing else present, or at least no products are present at that moment, then that reaction will proceed in the forward direction. Okay, and so you can see that here. So when you first place H2 and I2 into a flask, you initially have no HI products. As time goes on, the forward reaction will proceed, but it will start to slow down, and the reverse reaction will proceed and it will start to speed up. And that does make sense because as we form more of the products, we would see more of the reverse reaction occurring. And this will continue to be lying to the right for as long as the forward reaction rate is greater than that of the reverse reaction. So you can see that when a reaction is actually product favored, it will proceed in this direction regardless of the amounts that you start with. So if you start with a high concentration of HI and no concentration of H2I2, this is still going to proceed to a point where the HI is in greater concentration than the H2I2. We're going to talk about that later. This is a function of equilibrium, but this is still, in this case, this would be going in the reverse direction, but it's not going to do that. It's not going to favor the reverse reaction for very long. So sometimes reactions lie so far to the right that we say the reaction has gone to completion, and that would look something like this. And so you're used to seeing this because we assume when we're doing stoichiometric calculations that the reactions go to completion. So when a reaction goes to completion, your forward reaction proceeds to the point that we essentially consume all of the reactants and we don't really see a reverse reaction taking place. So you would see the concentration of the reactants would completely disappear and the concentration of the products would dominate. And so this is a reaction that lies very far to the right. The second situation you can have is when the rate of the forward reaction is less than the rate of the reverse reaction. So if we look at a situation like this, if we start with NO2, which is the product here, then you can see that the production of N2O4, the reverse reaction, proceeds here, right? So we're starting with no NO, and this is concentration, not rate on these graphs. So you can see that we proceed to accumulate N2O4, and then we see a decrease in the concentration of NO2. And then eventually we reach equilibrium, which we're going to look at in just a second. We can see a different situation here where we have, we're starting with N2O4 and we're not starting with NO2. And here you can see that we have a rapid accumulation of NO2, but then again, at some point at equilibrium, it would turn around and the forward reaction would no longer be favored. And then we can see even with pretty close to equal concentrations in this situation, we still have the concentration of N2O4 is favored and the concentration of NO2 is reducing. And so we know in this case that the reverse reaction is also favored. Okay, so we said that the reaction lies to the left because that's where your reactants are, and the reaction favors the reactants or the reverse reaction, and the reactants are formed faster than the products are formed. The final situation that we can have set up, and I'm going to keep the same graph up here, is that the rate of the forward reaction is equal to the reverse reaction.